Just like the last example, I'm going to start with the easiest pieces. I think those are the ordered pairs. F of 0 is negative 2. And f of 3 is 1. 1, 2, 3. I'm going to label that ordered pair since my point is not on an axis. Okay, where do we go next? I guess we'll go in order. X approaches 0. On the left of f is 0. So, I don't know if that's supposed to be coming down or up. I may have to fix that later, but I definitely need a hole at 0, 0, since f of 0 is negative 2. The limit as x approaches 0 on the right of f is negative 3. I'm fairly certain that tail goes up, but I'm not sure. We might have to fix that later. The limit as x approaches infinity of f is 0. So that's right-hand end behavior. That's going to trace along the positive x-axis. Oop, that was a little off. And the limit as x approaches negative infinity of f does not exist, going towards negative infinity. I'm going to put a reminder arrow down on the left-hand bottom corner. The limit as x approaches negative 4 on the left. Okay, so negative 1, negative 2, negative 3, negative 4. So negative 4 on the left does not exist and goes to negative infinity. You shouldn't need those dashed lines, but it's going to help remind me that vertical asymptote is to the left of negative 4. I wonder what happens to the right of negative 4. It doesn't say, so I'll do whatever I want. The limit as x approaches negative 1 of f is 3. The limit as x approaches negative 1 from both sides, 2, 3, is 3. 1, 2. So maybe we'll make this the ordered pair, negative 1, 3. And I can do whatever I want to connect that to the rest of the graph. That seems to be all 8. I like to connect the dots from left to right. And I also like to make continuous curves. I don't know what happens to the right of negative 4. I can do whatever I want. And I guess I feel like making a vertical asymptote. The next piece I have to connect with is this limit as x approaches negative 1 of f is 3. That's going to come down here to 0, do a little bit of erasing. And remember, we're not going to connect that dot. That was the limit as x approaches 0 on the left-hand side only. When x approaches 0 on the right, f approaches negative 3. And then I guess I just need to connect down here. Let's go through everything and make sure everything matches up. F of 0 is negative 2. F of 0 is negative 2. Looks good. Maybe make that a bigger dot. F of 3 is 1. F of 3 is 1. That seems pretty obvious, hopefully. X approaches 0 on the left of f is 0. Looks good. X approaches 0 on the right of f is negative 3. Maybe a label for negative 3, but that looks correct. X approaches infinity of f is 0. The right-hand end behavior of f is 0. Looks good. The limit as x approaches negative infinity of f does not exist at negative infinity. This graph dives down to the left. Looks good. The limit as x approaches negative 4 on the left of f does not exist. Sounds good. And the limit as x approaches negative 1 of f is 3. Limit as x approaches negative 1 from both sides is 3. That seems good. Your graph might look a little bit different, but these 8 pieces need to be the same. Last one. Let's start with the 3 ordered pairs. F of 1 is 5. 1, 2, 3, 4, 5. F of 3 is 2. And f of 0 is 3. I like ordered pairs. They make this sketching easier. Okay, the limit as x approaches 1 on the left is 5. Ooh, that's easy. The limit as x approaches 1 on the right is 8. Oh no. So that needs to be up here. I definitely need an open circle since f of 1 is already 5. So 1, 8. The limit as x approaches infinity of f is 1. The right-hand end behavior of f is y equals 1. Something like that. Oh, that was off the graph. The limit as x approaches negative infinity of f is negative 1. 1, 2, 3, 4. Okay. The limit as x approaches negative 1 on the right does not exist due to unbounded growth towards positive infinity. Negative 1. And the limit as x approaches negative 1 on the left-hand side of f does not exist due to unbounded growth towards negative infinity. All right, let's connect these dots from left to right. I know they're not dots. Okay, where does this go next? I think here to 3. Oh. Got to connect up here. And I guess I'll just do a nice smooth curve through 3, 2, out to the right.